Okay. So, today we talk about the accreditation. So, accreditation, what is accreditation, why accreditation is come. So, if we see that formal definition, that what is accreditation, meaning is meaning of accreditation, a broad definition of accreditation. Formal recognition of an educational program by an external body on the basis of assessment of quality. And evaluation is an evaluation process in which the objective group, this is the accreditation body, examine the educational program to ensure that it is meeting the minimum standard established by the expert in the field of the industry. So, the accreditation program, either the program is accredited or not accredited. So, this is the formal kind of definition. Think about why accreditation. Why with the accreditation term, accreditation terminology is required? Why you go for accreditation? Is accreditation produce better result? So, to understand why accreditation, so this is called that objective and subjective measurement of the quality. So, that means that anything, if I want to measure the quality, or I can say that the accreditation is a process for measuring the quality of a program. So, if it is like that if accreditation is meant for measure the quality of the program, that means we want to measure the quality of an education systems. Now, if we know how do you measure the quality of a product, system, process, whatever. Suppose this is the product. If I want to measure the quality of this product, how do I measure this? So, measurement of the quality has two processes. One is called subjective, another one is called objective. So, what is subjective measurement? Many people say this product is good, that is why this product is good. That is subjective measurement. Like that, when you want to buy a television from the markets, you go to the markets and either two way you select. Either you go to the market, find the product which is already predetermined based on the market survey. So, there is a product whose review is very good, above 4.5, or the company name Sony, you can say that okay, Sony product is good, so you buy the Sony television. So, that is subjective measurement. People saying this is good, that is why this is good. So, a program, similarly a program or an education system, I can say the education, see the education system is a broader definition. Let us start with a program, like the BTech is a program, MTech is a program. So, a program, whether it is good or bad, it can be measured two ways, either by subjective evaluation or by objective evaluation. Subjective evaluation, people saying this institute, this program is good, that is why that program is good. People saying the IIT computer science is very good program, that is why that program is good. How they develop the credibility? That is called brand name. They develop their brand name based on their alumni effort. So, it required a long term effort to establish the subjective quality of a program. So, pass out from that program, produce that brand name, that is why that program is good. So, that is called subjective measurement of the program. Now, subjective measurement maybe it is not 100% correct. Maybe let us 10 years back Sony television was very good television, but maybe today there is some brand is come out which is very good. So, if I go for subjective measurement, there is a time required to establish that brand name and also time required to brought down from the brand name to the brand name to the ground. So, in subjective measurement always time specific, in time span it can high and it can also goes down. Now, that is not that good. So, can I measure objectively the quality of the education program? So, can I say that objectively I have measured the quality of institute A program B and this is the quality index? Can I say that? So, if I want to say that, then suppose if I want to measure the objective quality of this pen or this kind of this product, I have to define certain parameter or dimension by which I can measure the quality of this device. Maybe the color, thickness, size, all kinds of parameter I have to define. So, similarly, if I want to measure the quality of a program, the requirement is to have to define the parameter by which I can measure the quality of that program. So, if I want to measure the quality, I have to fix the parameter. Who will fix the parameter? What should be the parameters? So, it is an educational program. If this is the product, then I can say the company who is manufacturing this, based on the technical specification, they make the features by which I can measure the quality of this product. Similarly, who will make the parameter set for measuring the quality of a particular educational program? So, you understand that a program quality can be measured by two ways, either subjective or objective. If I want to measure the objective, then it requires certain parameter by which I can measure the quality of the program or certain dimension. Who will establish or who will define those dimensions? To understand that phenomena, think about why accreditation is required. Why we want to measure the quality of the program? Suppose Institute A produce a student or Institute A run a program B and produce certain outcome, certain output or students. Those students will be acceptable by another Institute C on the what basis? So, actually the accreditation comes from the acceptability. What should be the minimum standard, so that this degree, program produce a degree, this degree will be validate in other institute or other country also. So, suppose somebody has done BTech from India, why USA say that I will take that BTech degree, or somebody done some BTech from some X country, why India will say that I will accept that BTech degree. So, what are the minimum criteria? What are the minimum criteria required? A students or a learner, if he claim that I have passed out from a particular program, those are the minimum skill set he must acquire. So, unless acquiring those skill set at the minimum level, I cannot validate that degree. So, accreditation actually benchmark the minimum requirement. It never said a student cannot exceed maximum, that is maybe maximum requirement. So, Institute A may produce 40 students, out of 40 students there will be 3-4 students who are exceptionally bright. They may achieve more higher than the minimum requirement, but accreditation guaranteed that all the students who has passed out from a particular program must maintain the minimum requirement of that program. So, to do that, there is an accreditation body. So, there is a second term, an evaluation process in which an objective group, accreditation body, examine an educational program to ensure that it meet the minimum standard established. Who define the minimum standard? Established by expert in the field of industry. So, somebody has to define the minimum standard, that these skills are essential for this kind of program, and somebody are measuring whether particular program are actually develop those skill on the students or not. So, this is the process of accreditation. So, if I want to do that, I have to define the minimum standard. So, who define it? There is a two, if you see that history of Washington Accords actually a accreditation criteria, or you can say that they have defined the set of parameter by which I can measure it after 10 plus 2 4-year program. It is not never said that it will be measured for MTech, BTech, PhD, not that. He said after 10 plus 2, generally a 4-year or more post secondary study, maybe 5-year program or maybe 4-year program. So, if I say the quality of a program after 10 plus 2 4-year program or let us 5-year program, that is defined by Washington Accords. So, a group of people sit together, define those criteria, those dimensions for measuring the educational program which is designed after 10 plus 2 4-year. So, Washington Accords actually define the criteria for measuring the educational program. What is those criteria? First one, many people say knowledge of engineering science, that means that they should have a knowledge, but they never said that. It is a heading, knowledge of engineering science is a heading. If you see the skill is solution of a complex engineering problem, they said the program must create a skill on the students should able to solve complex engineering problem. There is a two dimension. There is one is called skill. What is the skill? Skill is solution, solving ability of the students. What is the complexity of the ability? Complex engineering problem. So, if I say that this is the minimum skill which is the solution, solving ability of the, that is standard. It is not the knowledge. He should know definition of Newton's second law of motion, he should know definition of Maxwell equation, he should know describe that how AC machine works, not like that, that knowledge. They said a student must have a ability to solve engineering problem based on his mathematics, natural science and engineering fundamentals knowledge. So, whatever is studied in mathematics, engineering fundamentals and science, this he should apply those things to solve engineering problem. Now, if you see that there is a term complex, what is the meaning of complex? If it is said that Washington Accord never said that what is the maximum criteria. So, minimum criteria and the solving ability. Now, the complexity of the problem will differentiate institute to institute, unless I can say somebody can write down a one accreditation document, it is valid for everybody. No, because the complexity of the engineering problem may vary from institute to institute, program to program. So, a institute A, program B and another institute C, program B may not be same complex solution ability is there. Suppose institute A said in my program B, our purpose is to supply manpower to the local industry. So, we are not talking about the advanced research in the field of engineering. So, the complexity of the coverage, complexity of the subject may be low in that case. Let us give an example, let us IIT. There is a subject called thermodynamics in IIT. So, IIT thermodynamics, the complexity is much more higher Then the another institute, he want to produce only graduate engineer to for supply local industry. So, IIT mandate is to produce a high end research engineer. So, my complexity of the thermodynamics will be much more higher than the solution ability of thermodynamics in other institute. So, the complex engineering problem, the complexity will vary institute to institute. Somebody say, in my case second order differential equation is sufficient for my BTech program. Some institutes say no, our engineer will be do research, advanced research, second order differential is not sufficient, I have to go for the third order, fourth order, even nth order. So, that is complex engineering problem. It is not knowledge about define, describe or what is the value of this, derive this thing, not like that. The solution ability, the skill is solving ability, the complexity may vary. Next one, problem analysis. Student will able to analyze complex engineering problem. So, the ability is analyze, again complex engineering problem. So, complexity may vary, but ability is analyzing. I cannot say that I am not a good institution or I am producing engineer for employable local industry kind of things. So, my students are not knowing analysis, they know describe, not that. They have to know analysis, but the complexity of the analysis may less compared to other institutions. So, when you write your, when they define the PO, they only say the minimum skill set required is the analyzing ability. Complexity is varies from institute to institute. So, that is the issue. Unless what will happen? You can say, okay, if it is solving ability, analyzing ability, it is same for all institute. So, some institute produce a document and circulate to everybody and that is sufficient, but that is not. It is same as copying a syllabus. If I copy a syllabus of Harvard University or MIT, can my institute become MIT? So, it depends on your institute resources, institute the kind of input you get and you kind of output you want to produce, the complexity of the problem will change, but the ability of the engineer must be analyzing, not describing, define kind of things. Okay? So, this is called analyzing ability. Next one, design and development ability. The student must able to design solution for a complex engineering problem and design systems, component or a process. So, skill is design. Student must able to design a system or a part of a system or a process. Again, complex engineering problem. So, I cannot say my students only know how AC machine work, my student does not know how to design. No, the student should know how to design AC machine, but complexity of the kind of AC machine design may vary. Somebody say, okay, two-phase AC machine is sufficient for my purpose, but somebody say, no, I am producing a high-end research student, they should know this kind of complex AC machine. So, design is a skill. So, first skill is solving ability, analyzing ability, design ability. Next is investigation. See that requirement. Conduct investigation of a complex problem including design of experiment, analysis and interpretation of data, synthesis of information to provide valid conclusion. So, a student must know design of experiment, collection of data, analysis of data and synthesis of information to draw the valid conclusion from the data. So, it is not that okay, you do not touch the system, you just take the data and write the lab report. If you go to any institute and you find out that lab report and just ask for the last 10 year back lab report, you find all the lab report are same, but it is not that. The lab means testing ability. So, they should be able to design the experiment. Most of the labs, if you go there, connect this point to this point, connect this point to this point, and vary this one, take the reading, vary this one, take the reading, everything is laid down. Students will come in the class, they just connect this wire to this wire, this wire to this wire, they collect like this and that done. But that is not. They should know how to design the experiment. They should know how to collect the data. They should know how to write or how to find out the information or draw the conclusion from the data, analysis of the data, which is very important, which is missing. If you go for any institute, many of the engineering colleges are there, where you can go there, every lab report, there may be a kit also available. So, everything is written down, students come to the lab and just connect this point, some data, and they go to the hostels, find out the previous year lab report, oh, this data is not matching with this curve, they change the value and draw the data. But actual requirement is design of experiment, collection of data, analysis of data, draw a valid conclusion. So, solving ability, analyzing ability, design ability, testing ability. Next skill, modern tools uses. Today, I cannot say any engineering discipline, if you say any engineering discipline, if you take, there is a lot of tools available particular to that discipline. If a civil engineer say, I do not know how a CAD/CAM software, how to draw like this, can I accept him as a civil engineer? A VLSI, somebody has a VLSI engineer, somebody has studied, okay, I have done the VLSI circuits or VLSI design course in my BTech level, and he does not know how to write a single line VHDL code. Can I accept him a VLSI engineer? Somebody has done a signal processing. I have done my digital signal processing classes, but he does not know how to write a single line in MATLAB, any kind of digital signal processing problem. Can I consider him a digital signal processing engineer? So, today modern tools are essential part of any engineering student. I am talking about the BTech engineer, not diploma engineer, BTech engineering students. So, they should know how to synthesize using those tools. So, synthesis of the problem using those tools and what are the limitation of those tools. So, if you see that, first skill is solution ability, analyzing ability, design ability, testing ability, modern tools uses ability. All those are domain dependent skill. If I say electronics engineer, they know only modern tools uses which are used in electronics field. They only know the design of electronics thing, the engineering problem which is related to the electronics. Civil engineer know only engineering problem related to the civil. Similarly, I can say the solution of complex engineering problem, again I can say that it is domain dependent. So, all those 5 skills are domain dependent and those are written, if you see the color is blue. So, 1 solution ability, analyzing ability, design ability, investigation ability, modern tool uses ability, all are domain dependent parameters. Many people say that, sir, modern tools uses they will only know in the lab experiment only. Not this is not be true. Even any subject, theoretical subject may consist of use of modern tools. If I talk about the signal processing subject, which I know little bit, so if you see that if I not given to the students a project where they use MATLAB to synthesis a digital signal processing problem, how they know digital signal processing? So, it is not only theory, lab, all separation. Any theory subject may contain some part in modern tools and uses. A theory subject may contain some testing part also. They have to go to the laboratory and test it and find out the solution. So, it is not necessary that lab, core, all kinds of things. Ultimately, the skill is solution ability, analyzing ability, design ability, testing ability, modern tools uses ability means synthesis ability. So, those are the skill required for a B.Tech engineer. If it is civil, civil, if it is mechanical, mechanical. So, that is why it is called domain dependent PO, program outcome. Those are called PO. Why program outcome? Because those are the measurable skill which has to be acquired by the student at the end of the program. So, at the end of the program, all students must have skill, solution ability, design ability, analyzing ability, testing ability, modern tools uses ability, by which you can measure the quality of the program. Okay. So, this is domain dependent PO, domain dependent PO, or you can say domain specific PO, domain specific PO. The 1 to 5 are depends on the domains of engineering. If it is civil, goes for civil, if it is electronics, goes for electronics. So, that is why it is called PSO, program specific outcome. So, all your program specific outcome must be written using these 5 skill. Now, you may say that then the program specific outcome all are same. No. Some institute, let us just think about the electronics, B electronics and telecommunication, or B electronics. So, institute A also offer B electronics, institute B also offer electronics. What is the difference? Institute A may have a very good setup for producing engineer who are much more conversant with microwave. Institute B has a very good setup who are much more convenienced with VLSI expert. So, all the PSO when you write for Institute A, they will write towards inclination of specialist in microwave, but in this 5 dimension. For Institute A may say, I am producing an engineer who has a solution ability, analyzing ability, design ability, testing ability, modern tools uses for microwave much more. They know analog electronics, they have the ability there also, but much more proficient ability in microwave engineering. That is why the PSO of a particular program or a particular institute does not match with other institute PSO, unless we will say okay, I can design a PSO and distribute to everybody. So, have you understand? So, 1, 2, 3, 4, 5 PO. So, those 5 PO are actually designed for measuring the quality of a program related to their domain skill. Now, there is a domain independent skill. What are the domain independent skill? So, domain independent skill are, first one is individual and teamwork. Function effectively as an individual and as a member of a leader in a. So, I will describe in the next class. So, I just quickly cover that. So, there will be a 6, 7, 8, 9, 10, 11, 12. So, there is 12 PO. Out of 12 PO, 1, 2, 3, 4, 5 are domain specific. 6, 7, 8, 9, 10, 11 and 12 all are domain independent. So, those are called soft skill PO. It is not that I have to develop the domain engineer only require domain specific skills, solution ability, analyzing ability, design ability, testing ability, modern tools. Along with that, they require some domain independent skill also. What are those skills? Individual teamwork, communication skill, engineering and society, ethics, lifelong learning, project management and finance, all are important. So, basically the accreditation meaning is that design or accreditation body has defined a dimension, or you can say the set of parameter by which I can measure the quality of a program. So, Washington Accords for engineering education. If I want to measure the quality of our English honors program or general science program, then somebody has to define what are the minimum skill required by a general stream graduate students. Or I can say, why society will accept a person, a English honors graduate. What are the minimum skill you want to see on a student who say that I have passed the English honors? So, those are the parameters you have to define in terms of skill, which is specific, measurable, achievable. It is not somebody has defined, okay, you have to reach to the God, which is not achievable. So, I cannot show that. So, when you design that accreditation parameters, or you can say the PO, program outcome, it should be specific, measurable and achievable manner. Okay. So, next class I will discuss about the domain independent PO. Okay. Thank you.